Question requires us to use Simpson's rule to approximate the value of this integral here. And we are also given the number of strips that we are supposed to use. We're supposed to use 4 strips. First of all, we are going to calculate the width of each strip, and we are going to use this formula that you are seeing right here. In this case, our B is the upper limit, which is equal to 5. Our A is the lower limit, which is equal to 1. And our N, which is the number of strips, is equal to 4. So we are going to substitute these values here back into this formula, and we shall have the X being equal to 5 minus 1 out of 4. And our answer is going to be 1. So this is the width of each strip. After that, we are going to draw a table like this one here. X, Y here. So in this column of X, you're going to start with the lower boundary, 1, and we are going to keep on adding 1 until we reach the upper limit. So we are going to have 2 here, 3, 4, and 5. So we are going to substitute these values one by one back into these functions to get the corresponding value of y. So when we substitute 1 back, we get 1. When we substitute 2, we have 20. When you substitute 3, we have 81. When you substitute 4, we have 208. And when you substitute 5, we have 425. So after filling this table, we are going to use a formula to find the approximate value of the integral here. So our formula is S being equal to third times the X, which is the width of each strip, then open brackets into Y plus 4Y2 plus 2Y3 plus 4Y4 plus Y5. So here we are going to have a third, then multiplied by the width of our strips, which is 1. Then our first value here is going to be 1. Then plus 4 into our y2, which is 20. Then plus 2 into our y3, which is 81. Plus 4 into our y4, which is 208. Then 5. Our fifth y is 425. So when we simplify this, we are going to have a third into 1,500, and our final answer is going to be 500. So this is the approximate value of the integral that the question required us